So today we will learn Simpson's one-third rule in numerical integration. So first of all, what is integration? Integration does not just only the area under the curve effects from some interval within the interval a b, right? So that means integration gives area under the curve effects from x equals to a to x equals to b. Now, by analytical method, we have learned how to find out this definite integral, right, in 11 and 12. Now we will learn numerical integration. Now numerical integration is nothing but the approximation of this integral for some functions where analytical solutions are very difficult or impossible. Okay. Now very common methods are trapezoidal rule and Simpson's one-third rule in case of numerical integration. Now today we will discuss Simpson's one-third rule as we already discussed the trapezoidal rule in our previous video. Now in case of trapezoidal rule, what we do, we approximate the integrand by using first order polynomial. In case of trapezoidal rule, we approximate the integrand using a first order polynomial. And in case of Simpson's one-third rule, the integrand we approximate by using a second order polynomial or also called a parabolic arc. Okay. So Simpson's one-third rule is nothing but an extension. We can say that this is an extension of trapezoidal rule. Now, first of all, we will derive the Simpson's one-third rule. Now, here how to derive? What is the procedure for that? Suppose we want to find out okay, so this is the x-axis, this is the fx-axis or y-axis. So what to do? We have to find out the area under the curve this from x equals to a to x equals to b. That means within the specified interval ab. Now what we do? We divide this interval AB into n number of subdivisions. So n number of subdivisions means in this way we are dividing. Suppose I am here the last two divisions I am showing. So each of length should be same. Let it be h. So how to find out this value h? Whole interval, this length is simply b minus a. And how many divisions we are getting? N number of divisions. So simply b minus a divided by n gives the h, right? So this length is your nothing but h. Now this point a, suppose we are denoting this as x0. And the next point is your, suppose this is your x1. So in this way, b, the final value b, which is nothing but your xn, which is nothing but your xn. Now, what is your x1? x1 is nothing but x0 plus h. Similarly, the next point will be x2, x2 will be x1 plus h. In this way, lastly, xn. And what is your xn? xn is nothing but your, we can say xn minus 1 plus h or x0 plus nh. That means, see, here a which is equals to x0, xn which is equals to b, and here the condition is given that x1 minus x0, x2 minus x1, xt minus x2, xn minus xn minus 1 all are equal values and these are equals to h. And what is h? b minus a. Okay. Now the Simpson's one-third rule, the formula is this. Now how we will get this formula? Now we will talk about the derivation. So first of all, we are dividing this interval into n number of subdivisions, right? Next, what to do? Suppose we want to find out what? We want to find out a to b fx dx, right? Sorry. Fx dx. So we have to find out this value. Now this is nothing but we can write integration x naught to x naught plus nh. Why? Because a is nothing but your x naught, b is nothing but your x naught plus nh, fx dx. Now what we are doing, this fx I can use Newton's forward interpolation formula, Newton's backward interpolation formula, Lagrange's interpolation formula, or Newton's divided difference formula. Any one of this I can use for fx. Now here I am using of fx, I am using the Newton's forward interpolation formula. We know the formula is fx naught plus u into delta fx naught by 1 factorial plus u into u minus 1 into delta square fx naught by 2 factorial plus dot dot dot. So this is the Newton's forward interpolation formula. So as we this place fx by Newton's forward interpolation formula, here also we have the relation. What is the relation? U equal to x minus x naught by h, right? So from this, what I can say, x is equals to x naught plus uh. So if this happens, then what will be dx? Dx is nothing but h du. So here our here we have derived we have to integrate with respect to x, but now we have changed x into some new variable u. So here we have to integrate with respect to u, and also we have to change the limit. Now when x equals to x naught, what is the value of your u? Simply, when I am putting here x naught, u will be equal to x naught minus x naught, that means 0. So here it is 0. Now when x equals to xn, so when x equals to xn, the value will be xn minus x naught by h. Now what is your xn? Xn is just in the previous slide we have discussed that xn is nothing but x naught plus nh. Already written here, x naught plus nh. Xn is nothing but the b point. So x naught plus nh minus x naught remaining nh by h, that is simply n, right? So this is nothing but n. So the limit is becoming n. Now what to do? Just simply we have to integrate with respect to u, and this is the integration after putting the limits. Here h is constant, fx naught, delta fx naught, by factorial 1, delta square fx naught by factorial 2, all these are constant terms. Simply we have to integrate with respect to u, that is this u are the variables. So after integrating we will get this formula, and this is nothing but the general quadrature formula. Now in this general quadrature formula, if we put n equal to 1, we will get trapezoidal rule. If we put n equal to 2, we will get Simpson's one-third rule. Now we are putting n equal to 2 means, see the previous slide here I have written one term. This is 2m. What is 2m? Means the number of subdivisions n must be even. Let it be 2m. The number of subdivisions must be even in case of Simpson's one-third rule. So why? Because I am putting n equal to 2. Putting n equal to 2 means I am taking 2 subdivisions at a time. I am taking 2 subdivisions at a time. Okay, so when n equal to 2, if I put in the previous general quadrature formula, so what is this? The left hand side will be x naught to x naught plus 2h, and the right hand side will be h into 2fx naught plus 2 square by 2 delta fx naught plus, now 2 subdivisions means how many, suppose see the previous slide here, I am taking 2 subdivisions, means suppose this one and this one I am taking 2 subdivisions, right? Now in these 2 subdivisions, how many values of x are there? 3 values. 3 values of x, 3 values of fx. These are nothing but the fx. Fx means y naught, y1, y2, or fx naught, fx1, fx2, right? So with this 3 values of x, that is x naught, x1, x2, and here fx naught, or we can also say y naught, y1, y2. So I am simply writing y naught, y1, with these three values, if I make a forward difference table, so what will be the highest power of delta we will get? We will get next from this we will get two values. Here we will get one value, another value. Then from this two we will get simply one value. This will be for the delta, this will be for the delta square. All other higher order derivative will not, higher order forward difference will not exist, right? So in this case, what we will then do? What we will do? So in this case, simply I am getting up to second order, up to this order. When we are putting n equal to 2, all other we will neglect, all other terms we will neglect in case of Simpson's one-third rule. So after putting n equal to 2 here, we will get this type of thing. We will get this value. And this is for x0 to x0 plus 2h. So I am taking the first two divisions only. I am taking the first two divisions only. Suppose this is the first two divisions. I am taking the first two divisions only. Here we are having the curve, right? So for these two divisions, this is the area. Now if I take the next two divisions, means here it is x0, x1, x2. Now from x2, x3, then x4, what will be the area? The area will be this similar way. We can find out. So in this way, for the last two divisions, this is the area. So after adding all this, we will get the whole area, and the whole area is from A to B. A to B fx dx will be this. This is the Simpson's one-third rule. So this is the derivation of Simpson's one-third rule, right? Now, geometrically how we will get this? See, here at first we will already in the first or second slide I already mentioned that in case of trapezoidal rule, we will approximate the integrate by using first order polynomial. Means a straight line, right? Now in case of Simpson's one-third rule, what we do, we approximate the integrand by using second order polynomial or parabolic arc, right? So in this case, the black line is our given curve, right? Y dot of x, the black line curve. Now what we will do, I am taking two divisions at a time in case of Simpson's one-third rule. So I am taking these divisions and these divisions. Here the black line is the original curve, but here what we will do, we will approximate this integrand by using a parabolic arc like this. Okay. Now for the next two subdivisions, here again we have to approximate this integrand by using second order polynomial, means parabolic arc like this. Okay. So in this way, this is for the last two divisions. So in this way, we will here some area we are neglecting. In this case, some area we are introducing. More area we are introducing. So ultimately, some plus minus will happen, and ultimately error will come. That means we will get some approximate value in case of Simpson's one-third. Okay. So this is the geometrical interpretation of Simpson's one-third rule. Now, one more thing, this Simpson's one-third rule gives better result than trapezoidal rule. This is what advantage, right? And next, suppose we will do one problem. So here the question is, estimate the value of pi from integration 0 to 1 by 1 plus x square dx by Simpson's one-third rule taking n equal to 8. Now one more thing, here I have repeatedly told you that n must be even. N cannot be one odd number. Here in this case it is given, n equal to already 8 it is given. But sometimes it may not be given, then you have to assume on your own. But you have to assume such that n is an even number. Okay. And here this is your lower limit a, so I have written a equal to 0, and b equal to the upper limit, that is your 1. Now subdivision is 8 it is given, so equal to 8. Now, what is the h? Because I need h. Because see the formula, Simpson's 132 rule says the formula is this one. So what you need the value of h, you need the value of fx0, fx1, fx2, fx3 in this way, fxn. So all these functional values we need. So for that we have to make a table. So these are the values of x, and the values of x start from 0 up to 1, and the length is the length of x0 and x1. Here it is h, and h is 0.125. So x0 is 0, x1 is 0.125, x2 is 0.125 plus 0.125, that is 0.25. In this way, the last value is 1. The last value of x is 1. And similarly, how to find this fx? What is your fx? Fx is given 1 by 1 plus x square. Here, what is your fx? Fx is your 1 by 1 plus x square. So if I put x equals to 0, then I will get f of 0, that is 1 by 1 plus 0 square, that is 1. Now when x equals to 0.125, I will get 1 by 1 plus 0.125 whole square, that value will be this. In this way, 1 by 1 plus 1 square, that is 1 by 2, that is 0.5. So we are getting all the values of fx. Now what to do? Just use the Simpson's 132 formula. Here the formula is h by 3. What is your h? H is 0.125 by 3. Now what is your fx naught plus fxn? Fx naught is 1, fxn is 0.5, right? So this plus 4 into, here 4 into, we have to see odd term, means this fx1, this is your fx1, fx2, next I need fx3, fx4, fx5 I need, fx6, fx7 I need. Here it is. Okay, and plus 2 into sum of other terms. So ultimately, putting the values, calculating, we will get 0.7854. Okay, so this is the value by using Simpson's 132 rule. Now we have to estimate the value of pi. How we will do that? Estimate the value of pi means by using analytical method. What we can find out? By analytical method, integration 0 to 1, 1 by 1 plus x square dx, that is nothing but tan inverse x from 0 to 1, and after putting the limit, this is nothing but pi by 4. So by analytical method, the value is pi by 4. Now by Simpson's 1/3 rule, this is the value, right? So by equating this to, I will get pi by 4 equal to 0.7854. That means the value of pi is 3.1416 by using Simpson's 1/3 rule. So in this way, we have to do the problems in case of Simpson's 1/3 rule. Now the next question. Here, estimate the value of integration 0 to 1 sin x dx by Simpson's 1/3 rule. Now what is a here? Simply 0. What is b here? Simply 1. Lower limit 0, upper limit 1. What is your n? N is not mentioned. You have to assume on your own. Now how to assume? Just simply n should be an even number. So I can take n equal to 10. Okay. If I take n equal to 10, so what will be the value of h? 1 minus 0 by 10, that is equals to 0.1. Right? So now the values of x you must write. What is your x? The initial value of x is 0, then 0.1, then 0.2, 0.3, 0.4, 0.5. What to do? Simply with the previous one, you add 0.1, you will get the next one. 0.6, 0.7, 0.8, 0.9, and at last 1. Right? Now the values of fx we have to calculate. Here, what is your fx? What is your fx? Fx is your sin x, right? Now, when the limit is from 0 to 1, and here we are having trigonometrical function sin x, we have to use the radian mode in the calculator to calculate this value. Here it is sin 0, simply 0, that will be Now sine of 0.1. So I will calculate the values. Just in the radian mode, you have to calculate. Just 1 minute. So sine, I need 0.1. This value is 0.99 0.0998. I'm taking up to 4 decimal places. I'm taking up to 4 decimal places. Next, sine of 0.2. That should be also in radian mode. All the values should be in radian mode. I'm repeating this word. All the values should be in radian mode, not in degree mode. If you are using calculator, you have to change your mode. Now sine 0.2 is 0.1987. 0.1987. Okay. Next, 0.3 for 0.3, 0.2955. 0.2955. Okay. Next, 0.4 for 0.4, it is 0.3894. 0.3894. Next, for 0.5, it is 0.4794. 0.4794. Next, for 0.6, it is 0.5646. 0.5646. Okay. Next, for 0.7, it is 0.6442. 0.6442. Next, for 0.8, it is 0.7174. 7174. Next, for 0.9, it is 0.7833. 0.7833. Next, for 1, it is 0.8415. 0.8415. So these are the values, right? So now this is the Simpson's one-third rule. So what to do? Just put the values. What is your h? 0.1/3. Done. Now fx naught plus fxn. Fx naught plus fxn. Fx naught is 0 plus fxn is 0.8415. 0.8415. Okay, done. Plus 4 into what? I have to write 4 into this one, this one, this one, this one, and this one. So 0.0998 plus 0. I think this value is not 2955 plus 0.474794 plus 0.6442 plus 0.7833. Done. Plus what is remaining? This is remaining, this is remaining, this is remaining, this is remaining. So those must be multiple of 2. 2 into 0.1987 plus 0.3894 okay, plus 5.5696 plus 0.7174. 0.7174. So if I calculate this value, I will get the value is your 0.4597. So the value will be 0.4597. Okay. So in this way we have to do the problems. Next, and the last topic, degree of precision. Now, degree of precision, the definition is given here. A quadrature formula is said to have a degree of precision k, which is greater than 0. If it is exact, that is, the error is 0 for any arbitrary polynomial of degree less or equal to k. But it gives some error when we are taking one polynomial, and there must exist at least one polynomial whose degree is k plus 1 or k plus 1, for which it is not exact. Then what we will say? We will say that the degree of precision of that quadrature formula is your k. Okay, right? Now here in case of Simpson's one-third rule, I have written the error term. See the error term. Error terms. Why the error comes, that I have discussed already when we are discussing the geometrical representation. Now in the error term, the derivation of error term is also there, but it will take some more time. Now just remember the error term. Here we are having a4 gyre. A4 gyre means fourth order derivative, where gyre is a point within the interval AB, right? So here this error term includes fourth order derivative of that function fx, right? In this case, suppose I am taking fx as a polynomial of degree 1. If I take up the polynomial of degree 1, then what will be the polynomial of degree, suppose 0. Polynomial of degree 0 means constant term I am taking. Now if I taking a constant term, so what will be the first order derivative? That will be simply 0. Okay. So that means error term will be 0. If for xi, of course it will be 0. For first order derivative 0 means second order, third order, fourth order, all will be 0. Similarly, suppose fx is a polynomial of degree, suppose I am taking 1. Then what will be the first order derivative of fx? I will get some value. But the second order and the rest, the more than 2, we will get the value will get 0. That means when we are putting this value, that will be 0, means no error will be there. So now if I take fx as a polynomial of degree 2, suppose I am taking up the polynomial of degree 2. So if I am taking a polynomial of degree 2, suppose I am taking fx is a polynomial of degree 2. Now what is delta of fx? What will be delta of fx? Delta of fx will be a polynomial of degree 1. Delta square fx will be a polynomial of degree 0, means constant value. Now when delta cube and higher order we will get, that then we will get 0, means fourth order we will get 0. Now in this way, if I take one third order polynomial, then also the fourth order will be 0. Okay, but when I am taking the fourth order, then when I am taking one fourth order polynomial, then we will get when we will get our third order polynomial, fourth order polynomial, we will get some value for this. That means the error will exist there. That means up to third order we are getting no error, but when we are taking a fourth order polynomial, we are getting some error term. That means by the definition of degree of precision, what is the Simpson's one-third rule? Degree of precision for Simpson's one-third rule, this will be 3, of course, right? So for today we are ending here. Thank you very much.